Hello, my name is Thomas Hazort, and this is the explanation video for assignment 7, which is over Q learning. So first thing we want to do is obviously import the required libraries and then make the environment the mountain car environment that we got from the AI gym. So first things we're going to do is just take a random action from the environment space and then set the all of these variables to taking that random action in the environment. And then we just print out some of the variables, which you can see here, what action it is, the observation it's made. You can see all that here. And then these are just setting variables that we need to know. So like we discrete it to 20 buckets. I'll explain why we do that in a minute. And then we set the observations into this array, and then we set a Q table where it is the observation and action equals the Q value. And then we make this function to make discrete. So all that does is just set these continuous values into discrete values. We do this because you need to pull from the Q table the Q value for that action, but if it's a non-discrete value, it's going to be a long float. So you want to discretize it so you can actually pull it from the actual tables, and so that you can get the actual value. And in this function, get greedy action, that just greedily chooses the highest Q value in the Q table and then returns that action. So now that we have that done, here's the first exercise. We need to fill in these. So for this select action function, we want a random 0, 1, so we just do random num equals random.random. And then if that number is less than the exploration rate, we get a random choice between 0, 1, and 2, which means we take 0, 1, and 2 with equal probability. And then if not, we do this greedy action and then return the action that we do. And then we just set these variables, epsilon start, epsilon decay rate, epsilon minimum. These are just variables that we'll be using in some of the formulas. And we set the maximum episodes that we want to go down, or the maximum steps we want to go down per episode. And the maximum episodes here, 5,000, learning rate of 0.1, and a gamma of 0.99. And so for exercise 2, we're actually implementing the Q learning algorithm, which you can see right here. And so we have this bit of code, and in this right here is where we actually need to implement the algorithm in code. So I'll explain a bit what this is. For each episode, we want to set the time step to 0, score to 0, and it's not done. The current observation, we're resetting it, and then we're discretizing it. And so while it's not done, take the greedy action with the current observation. In the action, you select the action with the current exploration rate and the greedy action that we just got before. And then these values are just with the next step that we're taking. And then we are discretizing it again. And then we're getting the next action again with get greedy action with the next observation this time. And okay, yeah. So it's this is the function that we needed to implement. So yeah. So basically, we're just implementing this formula right here. So the Q table with the current observation and action equals the current observation and action plus the learning rate times all of this, which is the reward plus the gamma value that we said earlier times the Q table of the next observation and the next action minus the table for the current observation and action. So it's whatever the value is for the proposed action and the observation that it'll take minus the current Q value. And then we just up the timestamp, stuff like that, and then set some of the variables to be printed. And you can see that right here. And it prints a lot because it takes a while to learn. And yeah, now we've plot the learning rate. So as you can see, at first it's really, really bad, and then it gets better and better and better until it kind of fizzles out and gets about as good as it's going to get. And we can see that here as well with this code. This is that. This is what it should look like. And then we do this function to record a video of what it looks like after learning the correct key values, and it should know what actions to take, and it's going to look like something like this video right here, where it knows to go back and forth all the way up into the flag with the minimum number of time steps required, or at least the minimum number that it learned. And so yeah, that is my explanation for the assignment 7. Thank you.